Hi students, in this video I'm going to do a real quick revisions on properties of circles. I'll be going through all the different properties of circles, and after which we'll do 1 or 2 O-level questions using these concepts that we have learned. Right, so let's do the first angle property, that's angle in the same segment. So to apply this concept correctly, we need to identify an arc. So what is an arc? An arc is basically just part of a circumference of the circle. Right, so that's an arc. So from the two endpoints of the arc, we can project an angle at the circumference of the circle. Right, so this angle must touch the circumference of the circle. And then from the same two endpoints, I can project another angle and another one. So all this angle will have the same value. So if I call one of them alpha, the rest will all be alpha. So in other words, if alpha is 30 degrees, all this angle will be equals to 30 degrees. All right, so what is not angle in the same segment? I'm just going to give you an example, which is not angle in the same segment. It could be like this. Okay, so you have the same arc here. However, the second angle that does not touch the circumference of the circle. Can you see? This one touches the circumference, but this one does not. So this is not. Okay, this is not angle in the same segment, right? Another example is this. You can have two angles, both touching the circumference of the circle. However, they don't come from the same arc. Can you see? This one comes from here, but the other one is this arc here, the green color one. So they don't come from the same arc. So therefore, this is not angle in the same segment. Right, let's look at the second angle property. That's angle at the center equals to two angles as a circumference. And this one here, it's the short form. Right. So basically, we still start off with finding an arc, recognizing an arc. But now this arc, the two endpoints of the arc will subtend an angle at the center now. It will subtend an angle at the center, no longer at the circumference, but at the center. So we have look up for the center. So usually in the questions, they will tell you that the center, it's mark O. The center of the circle, it's mark O, something like that. So here our center of the circle is mark X. So that's angle at the center. And from the same endpoints of the arc, I can subtend an angle at the circumference. This is the angle at the circumference. This one is at the center. So if the angle at the center it's 2 alpha, then the angle at the circumference will be alpha. This is what I mean by angle at the center equals to 2 angle at the circumference. So from the same arc, I can find some more angles. You know, remember the first angle property we learned, angle at the same segment. So that will be alpha also, right? And we can have another one also, right? That is also alpha. So this is angle at the center equals to two angles as a circumference. All right. Sometimes the angle, not the angle, sorry, the arc given to you is not a minor arc, it's a major arc. What do you mean by major arc? For example, it could be this arc here, and this is the angle, this is the center of the circle, right? So the angle that we are referring to, right, is this reflex angle here. Okay, this is the reflex angle we're talking about. So let's say if this angle it's 2 alpha, right? So using the same arc, the two endpoints of the arc, right? Okay, we can subtend an angle at the circumference. So the angle that subtend at the circumference will be this angle here. And this guy here will be alpha. Okay, so the key points about using this angle at the center equals to 2 angle at the circumference is to look out for the arc. Look out for the arc. Okay, let me give you another example. Let's say this arc, major arc, usually is a major arc. I'm interested here is this guy here. And then the two endpoints, from the two endpoints of the arc, right, you can subtend an angle at the center. This is our center, I call it O. Right, so the angle here will be 2 alpha. Then using the two endpoint, all right, you can subtend an angle at the circumference. And this angle will be alpha. Okay, so if we use back the same diagram as what I have drawn here early on, right, if this is the angle that I'm interested in, the reflex angle, I'm going to call it 2 theta. Right, so that means the arc that I'm interested in, let's use a different color, will be this one here, the one highlighted in yellow. Okay, and from that, I can draw an angle here, and this angle will be theta. So this is what it means. Right, let's look at the third angle property, that is right angle in the semicircle. The short form is this. Right, so the first thing to look out for is a diameter. Okay, diameter is equals to 2 radius. It passes through the center of the circle. Right, and from the diameter, all right, the two endpoints of the diameter, all right, we will subtend an arc at the circumference. Okay, look for the semicircle, and from there, yes, okay, so that is 90 degrees. Let's have another one. Right, it can also go below your diameter. So basically, just look up for the diameter, look up for a semicircle. So from the diameter, you subtend an arc at the circumference, so that will be 90. So that is right angle in a semicircle. Right, so the fourth angle property is angle in opposite segment. So what is angle in opposite segment? First of all, we look out for a cyclic chord. Okay, it's a quadrilateral, but it's inside a circle. So very important things to take note of is all these points must touch the circumference of the circle. It must touch the circumference of a circle. So what is angle in opposite segment? All right, so supposing this angle here, all right, if this angle, let's say I call it theta, then the one opposite will be this angle here. So this guy here will be 180 minus theta. Okay, right, it can also be this angle here. Let's say this angle here, I'm going to call it alpha. Then the opposite angle will be this one here. You can just draw arrow. So this angle here will be 180 minus alpha. This is what it means by angle in opposite segment. Alright, so look up for a quadrilateral where all the 4 points must touch the circumference of the circle. Alright, what it's not angle in the same segment, just give you one example. Okay, if you have a quadrilateral like that, this is not a cyclic chord because this point here does not touch the circumference of the circle. So this is wrong. Okay. Right, so let's look at another angle property that's tangent perpendicular to radius. This is not new to us, but let's do a recap. So first of all, we need to identify the center of the circle, which is very important, and identify a radius. Oh, sorry, identify a tangent. Basically, a tangent line is just a line that touches the circle at one point only, and this tangent will be perpendicular to the radius. That will be 90 degrees. So the things to take note of is a radius, the center of the circle, and the line that only touches the circle at one point. So that is tangent perpendicular to radius. Right, this is another very important angle property that you have to take notes of. That is tangent from external point. So let's start off by having a circle with the center of the circle labeled as O. Let's start off by having a radius. Alright, and we know that the tangent is perpendicular to the radius. Tangent perpendicular to radius. So that will be 90 degrees. Alright, I can have another tangent. Alright. But before I can have a tangent, let's have another radius. Right, and that angle is 90 also. You will see that this triangle, alright, if we draw a line from O, yes, it will divide this quadrilateral into two congruent triangle. You can use RHS to prove that these two triangles are congruent. Right, and yes, when they're congruent means the two angles are the same, and yes, the other two angles are also the same. That's called tangent from external point. Right, so with all these angle properties, you have learned, let's try to attempt an O-level questions. Right, so you're given the diagram. On the diagram, you're given the circle ABCDE with center O. right? You're given that CT and ET are tangents to the circle, right? So if they're tangent to the circle, then this one will be 90 degrees, this will be 90 degrees, right? And then you're given the angle CAE, it's 68, DET is 32. Okay, fine, giving reasons. All right, so you need to give reasons for all the angle properties that you use. Angle EBC, EBC. So we need to find this angle here. So how do we find the angle? All right. So what you do is that this is the angle. We need to look out for the arc. The arc. Remember the arc that subtends this angle. So if you have a highlighter, you can just trace it out like that. So the arc that subtends this angle will be this one here, highlighted for you in yellow. Okay, and then so from the same arc, can you see that I can subtend another angle at the circumference. So basically these two angles are the same, right? So therefore part I right, so for part I, angle EBC would be equals to 68 degrees, and the reason is angle in the same segment. All right, let's look at part 2. We're asked to find angle CDE. All right, so there's one thing good about using a soft copy, because I can just erase erase all the things I've highlighted. Okay, angle CDE. So basically this is the angle that I need to find. CDE. Wait. This angle here. All right. So what we're looking for is the quadrilateral. Okay. All right. Can you see that there's a cyclic chord? Right. This is a cyclic chord. And what do we learn about the angles in the cyclic chord? Right. You can draw arrow. Right. So therefore the angle CDE, right, would be equals to 180 minus 68. 180 minus 68. That gives you 112 degrees. All right, and the reason is angle in opposite segment. Okay, angle in opposite segment will add up to be 180 degrees. Okay, right, so that it's part 2. All right, so part 3, let me erase this off. Part 3, you asked to find CTE. CTE. C. Okay, right. So this is where we use the property tangent from external point, right? Look out for these two. These are the two tangent, and this is called the external point. All right, T is called the external point. Right, so we are finding what do we need to find? CTE. So we need to find this angle, question mark, right? Okay, so first of all, just now we mentioned that that is 90 degrees. This is also 90, right? Okay, so let's write down the reason first. Part 3. Let's write down that the angle TCO, it's equals to angle TEO equals to 90 degrees, and the reason is because tangent is perpendicular to radius, right? Okay, so I still need to find this angle here, right? This is a question mark. All right, so the angle, the arc that subtends this angle will be this one here. Then from the same arc, can you see that I can subtend an angle at the circumference? So therefore, this particular angle here, it's twice of 68. Its angle at the center equals to 2 angle at the circumference. So it's 68 times 2. which give you 136. Right, so angle COE, it's equals to 68 times 2 gives you 136. So the reason means angle at center gives you 2 angles at the circumference. Right, so with all these angles found, we can go on to find angle CTE, which is basically 360, because the sum of angle in the quad comprises of 2 triangles, which is, so one triangle is 180, right? 2 triangle will be 360. So 360 minus away 90 times 2 minus away 136. So that will gives you 44 degrees. And the reason is angle sum in the quad. Alright, so that's part 3. So part 4, find angle OCD. OCD. Alright, let's erase this. So angle OCD will refer to this angle here. Okay? Alright, so let's write down the angles that we have already found earlier on. So this one is 68 degrees. We found this to be 136. Okay. Okay, right. So if this is 90 degrees, we can use 90 minus 32 to get 58 here. Alright. So okay, so we need to write down each steps properly. Okay, so I'm going to do part 4 here. Right, so we need to explain that the angle, we already explained that OET, it's 90 degrees, so we don't need to explain that anymore. But angle OED would just be 90 minus 32 gives you 58 degrees. Alright, and then, okay, so this is also a cyclic quad, right? So this angle here will be add up to be 180. So we can find angle CDE, which is 180 minus 68. That gives you 112. Oh, we already found CDE earlier on. Ah, Lamat. Okay, sorry. I already found CDE earlier on. Forgot about it. So let's put it in here. That is 112 CDE. Right, we found in part 2 already. Okay, so that is easy. If I found all this ready, I can just use this. Alright, use this quad. So therefore, angle OCD will be just 360 again, because it's a quad. Minus away 136 minus 112 minus 58. And that gives you 54 degrees. So the reason it's the angle sum in a quad. Alright, so this is how you we can make use of all the angle properties we have learned to solve these questions.